Okay, you are welcome to Lawrence's lecture on the proof of cosine rule. We're going to make it very easy. We are going to prove cosine rule from one very important topic also in mathematics, and the topic is Pythagoras theorem. Pythagoras theorem. This Pythagoras theorem has the rule. It says that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Well, with this, the cosine rule has it that because Pythagoras theorem is mostly applied to right angle triangles. A triangle of this form, a triangle with one angle being 90 degrees and the other two angles sharing amongst themselves the rest of the 90 degrees left. So with that, here is the hypotenuse with a defined angle here, then here will be the opposite, then here will be the adjacent. But let us know how to find the size of a triangle if the triangle is not a right angle triangle. It is very easy for us to find the size of a triangle if the triangle is a right angle triangle. Using the Pythagoras theorem, we will be able to find it. But if the triangle is not a right angle triangle as we have here, like this triangle, upon seeing it, you get to know that it's definitely not a right angle triangle. So where is the opposite? Where is the hypotenuse? Where is the adjacent? We will borrow the idea from Pythagoras theorem to prove the idea of cosine rule. So we will use cosine rule or sine rule to find the sides and the angles in a triangle which is not a right angle triangle. So assuming we call this side small a, then the angle opposite to it will be capital A, or the angle it subtends will be capital A. If this side is small b, then the angle it subtends is capital B. Do you see that? Very good. And if this side is small c, then the angle it subtends is capital C. Well, with this triangle in mind, we can borrow the idea of Pythagoras theorem to find the cosine rule, which states that a square equals b squared plus c squared minus 2bc cos A. Contrapositively, or in any other form, we can also find b squared in that manner. B squared equals a squared plus c squared minus 2ac cos B, and c squared is equal to b squared plus a squared minus 2ab cos C. This is a cosine rule. How do we prove this cosine rule? How do we prove it? Using the triangle here, we can prove this cosine rule. Let us try to make the triangle, though it is not a right angle triangle, we can form a right angle triangle from this by drawing a perpendicular from point A to the line A. So we draw a perpendicular through the angle A to line A, so that we have a right angle triangle. You understand? Very good. After making one right angle triangle, so we have two right angle triangles in the triangle that we have drawn here. So we could call the right angle triangle the perpendicular height h, and we could also call this side to this side, because this side to this side is a. If we say here is x, then here is a minus x. What is left? If this part to this part is x, then from this part to this part is a minus x. With that in view, we could find b squared, or we could find b, or we could find h. We could do anything. We could do anything we like, but h is common in this right angle triangle, and it is also common in this right angle triangle. So we can find h according to this right angle triangle and h according to that. You see, they will be different, but because they are all is the same h, we compare them, we can say they are equal, and then we solve for the variable that will stand out. Okay, so h in this triangle, how can we find it? Because we have our b and we have our angle, and we have this, we can find h in this right angle triangle. So h in this right angle triangle is h squared equals b squared minus s squared. Using the Pythagoras theorem, do you see that the Pythagoras theorem here, but this h is the hypotenuse here, but this h is the height. You understand? Very good. So using the Pythagoras theorem, you could know that the h is opposite the angle defined, C. So we can say that then if we have to use this Pythagoras theorem, we can tell the formula for O, or the opposite, which has really transcended into h here. So h squared is equal to b squared minus x squared. Then what about h with respect to this part of the triangle, this part of the triangle, this? Well, that one also, get it? H squared equals c squared minus a minus x squared. So we could see that this h and this h squared, h squared, h squared, h squared, h squared, they are equal. So b squared minus s squared equals c squared minus a minus x all squared. So we'll put them together. So we will say that b squared minus s squared equals c squared minus, well, into bracket, if you expand this, you get a squared minus 2ax, right, plus s squared. Then you have b squared minus s squared equals c squared minus a squared minus plus 2ax plus s squared. Minus s squared. Do you see that? No mistakes. Since we see that b squared is standing out here, we can find the cosine rule. B squared equals a squared plus c squared minus 2ac cos capital B. Thank you. So, what we come here, we leave b squared, or we let it stand alone. Then s squared goes there, as we normally say. We have to add s squared here and add s squared here too, right? That's how it's supposed to be, so that it deals away with the s squared. But in mathematics, we normally say that s squared goes there. So x squared goes there. Then you have c squared minus a squared plus 2ax and minus x squared. Then with this x squared is minus here, it becomes plus. So minus x squared plus x squared, you don't have to write anything at all. So look at what we have. B squared equals c squared minus a squared plus 2ax. We are almost getting the cosine rule, but there is something we need to do. This is not the cosine rule, where from this x we need to do away with the x. The cosine rule says that this is b squared equals a squared plus c squared minus 2ac cos b, capital B. Yes. So this is what we do. B squared. But you see x, how can we find x? Look here, where a minus x is. There is cos b there. So we can find x in terms of cos b. Then we will go down. We say that cos b is equal to cos k. It is adjacent, which is a minus x, right? Over what? Hypotenuse, which is what? C. Adjacent over hypotenuse. Please, here is it. Can you see it? Yes. Cos b equals a minus x over c. So this is how we go about it. So you have c cos b equals what? Equals a minus x. Do you see that? We cross multiplied. We have c cos b equals a minus x. Because we want to do away with this x, we want to find the value of x in terms of cos and a and the variables we need here. So we see that this s will be equal to a minus cos b. So we come back into our formula. Let's call our formula equation 1. So putting this x equals a minus cos b into equation 1, we will have b squared equals c squared minus a squared plus 2a into a minus cos b. If we expand this, b squared equals c squared minus a squared plus 2a squared, c plus 2a squared, this one expanding to plus 2a squared minus 2a, see, so this is, you're supposed to get c cos c, c cos b. Here's c cos b. So actually a x equals a minus c cos b. So here is c cos b, right? So you get 2ac cos b. Do you see what we've gotten now? Do you see what we've gotten? So b squared equals c squared minus a squared plus 2a squared minus 2ac cos b. A squared plus 2a squared is a squared. So we get finally b squared equals c squared plus a squared minus 2ac cos b. 2ac cos b. Now this is what we have. That is the cosine rule. If you want to rearrange it well, you could say this b squared equals the a squared will come first, alphabetically, a squared plus c squared minus 2ac cos b. Cosine rule has been proved. Do you get it? That's very simple. And I plead with you to forgive me for bad camera quality. I took the video myself, so there's a lot of problem with it. I hope next time I will have a good camera quality. The next formula I'll be proving will be seen in my next video, so you can check it out on my next upload and you will be able to understand mathematics. I want us to get close to mathematics. Thank you very much for your time.